Hi, this is Jeffrey from Graphfinancials. So today we're going to do an introduction about the third generation of solar panels, and in the context of LONGi, because there is a bit of misunderstanding from many people thinking that solar panels are inefficient, that they will never get to parity, and there's no future in that. Well, we'll get to the point that it's already in parity in China, but before that, we are going to talk about the main reason for this situation, which is the introduction to third generation perovskite solar panels. So what are perovskite solar panels? Perovskite technology is based on two layers. They are different band gaps, in other words, wavelength of energy and spectrum, and then the silicon has a band gap of 1.1 eV, which means that it is great for absorbing infrared and red light, but wastes energy from high energy blue UV photon at heat. Okay. So perovskite typically has a band gap of 1.6 to 1.8 eV, and this is a second layer that is going to absorb high energy photon first, convert them more efficiently. So in tandem, you have the same silicon base to extract more energy, and you put a very thin, efficient perovskite layer on top, and that's the key to achieve levels of efficiency at 34.85 in labs in tandem solar. That's what LONGi is achieving in lab, and this is going to be rolled out maybe in 18 months. So what it means is that we are probably at 25. It increases dramatically the efficiency, and then the cost per cost per watt per square meter. So in other words, you produce a lot more watt per square meter, and you produce a lot more watts per unit of cost. Okay, so that's what matters, the cost per watt, and we are going to get to a point where it's going to fall dramatically. The cost per square meter with the current silicon technology is 10 to 12 cents. And it's already at parity. We'll see that in the next episode. But at this point, the perovskite is going to change dramatically the situation. All right? So the deposition of perovskite on its own is very different from silicon, because silicon is requiring is very expensive to produce in terms of energy. But perovskite is basically a deposition. It's a simple deposition technology. It's a roll-to-roll coating, slug die coating, and it's not expensive to do per square meter. Okay, but it's going to capture the blue bandwidth. Now, so what are we? For perovskite, there is no sense of rare material that are needed to produce this additional layer, which is boosting dramatically the efficiency and making the cost of electricity plunging way below the certain competitive technology. And we'll see that. It's going to be very interesting in the next future episode. Now, passivation is a process where you have defects on the layer of the silicon, and there was PERC, which is one technology. There was also TOPCon, which is another technology. There is heterojunction, and all of that is to correct the imperfections on the layer, on the surface, to capture more of the energy on the silicon. And those passivation technology have been changed and have increased progressively the yield of solar panel on silicon. Now let's look at the. So there has been a shift from heterojunction, from PERC to TOPCon, as we mentioned. And there is also the question of back contact, which means putting the contacts in the back of the panel to increase the yield instead of putting in the front and hiding and getting less surface. So PERC, we're at 22, 23. TOPCon has moved to 24. The next generation is a huge jump. This is the perovskite jump. Okay. Now, are we going to see less silicon used because there's a base layer of silicon which is being used? And not yet, but there is a history in the past of layers of silicon thinner and thinner. So not only the cost of producing polysilicon has gone down, but also the thickness, the quantity of silicon used has been going down. Now on the situation of perovskite, we are still at 150, whereas TOPCon is actually thinner technology. Are we going to see thinner attempts to put even less silicon on the tandem, which is solid silicon plus perovskite? It's very probable. So that's what is the context. The summary is that people have assumed that we are reaching a limit and this is a disaster. There's too much of a capacity. We'll never reach parity. First, we're already at parity. Second, there is something coming which is going to make it very, very competitive, and that will lead us to understand what's going on with green hydrogen and the demand for that versus gray hydrogen in the for industrial uses. Thank you very much. Bye-bye.